excuse me, not 13, 14. 14 is where we're at. All right, 14 from our review. 14 deals with a parabola. It says we have a reflecting telescope. It's shaped like a paraboloid of revolution. Mirrors 22 inches across at its opening and 4 feet deep. Okay. So we need an equation in order to find whatever it is we're looking for. In this case, we're asked to find where the light would be concentrated, which would be where the focus is. So to get an equation, sometimes a quick little sketch will help me. I can put, if I'm creating my sketch, I can put my vertex of the parabola anywhere I want. I'm going to pick 0, 0, just because it gives me some easier numbers to work with. And I'm going to have this parabola open up. Okay? Like something like this. And it doesn't have to be the most perfect thing. I'm just trying to get a rough sketch. And I do know some endpoints because it told me that it is 22 inches across at the opening. So if I were 22 inches across, that would have to be 11. And this one, negative 11. And then it says that it's 4 feet deep. All right, 4 feet deep. The biggest issue I have here on this problem, or one of the issues I should say, I'm dealing in two different units. I have inches and feet. I need to be in the same unit. So I could either go back and change that 11 inches or 22 inches to feet, or I could change the 4 feet to inches. I'm just going to change the 4 feet. So that would make that 48 inches. I need to be in the same unit. Obviously, this is not going to be drawn to scale because it should be much taller at 48, but I'm just trying to get a general sketch to kind of help me get my equation set up. So my standard form for parabola opening up, x minus h squared is a positive 4a, y minus k. I know the vertex already, 0, 0. So go ahead and make that x squared, 4ay. And I'm looking for where the light would be concentrated. So that would be how far the focus is from the vertex, which would be this a distance, how far it is. So I'm going to have a focus sitting right here. And I just wanted to know, hey, what's that value going to be? What's that a value going to be? Well, I do have a point. I can use either one of them, negative 1148 or 1148. So that would be 11 squared, 4a times 48. And let's see, and it wouldn't matter if I use the negative because negative 11 squared is going to be the same as 11 squared. So that would be 121 over, and let's see, 4 times 48, 192, I believe. 192. So 121 over 192 inches. So how far I'm away. Or if I go to a decimal, I could say 0.63 inches. It doesn't matter as far as a decimal or fractional answer. Either way would be acceptable. 15. Get my equation up here. Nine. 15, we have an ellipse, and we're asked to figure out the center, the foci, and the vertices of the ellipse. The center is going to be that HK value. So looking at my equation, I can tell that the center is going to be at 1, negative 2. But as far as figuring out where the vertices and foci are, I need to know which way it's oriented. So what I need to remember is, since the larger value is under the x, this is telling me that this is a horizontal ellipse. In other words, it's been stretched horizontally or stretched in that x direction. So looks something like that. My center, 1, -2. I need my A and C values for the vertices and the foci. A is the root of 16, which is 4. B is the root of 9, which is 3. And then C would be root 7. So C squared was A squared minus B squared. So 16 minus 9 is 7, making C then root 7. My vertices would then be 4 units away from the center and would have to move left and right. So that would be 5, -2, -3, -2. Now, again, 4 units away, left and right. I want to remember sometimes a quick plot can help me with where things are located. So if I'm more of that visual learner, I definitely want to come in here and go, all right, center's at 1, -2. Here we go. I'm going to count 4 units. 1, 2, 3, 4. There's that 5, -2. 1, 2, 3, 4. And there's that -3, -2. Now it asked me for the vertices. If I'm asked for the vertices, it is referring to the major vertices. Okay. If I was not asked in this one to draw it, but if I were asked to draw it, I would need the minor vertices. So we'll go ahead and list that for this problem. So again, I know it's going something like this, but I need to go minor, so how far up and down from that center, and that would be that B value. And 3 units up from the center would be 1, 1. 3 units down would be 1, -5. And 1, 1, 1, 3, 4, 5. And that gives me my ellipse there. Not the best looking drawing for me, especially since I've got it kind of on an angle and everything. But again, on a test, you have a nice grid. And I also want to stress that this one did not ask me to graph it. So I just wanted to throw that in there, that in case I was asked to graph it, I would need the minor ones to know how far up and down from the center in this case. Let me get the last piece I was asked for. Okay. So that would be root 7 away from the center. Would have to be left and right. So I can write that as 1 plus or minus root 7, -2. If I don't like dealing with the radicals, if I'm not comfortable with that, I can certainly, excuse me, go to decimals. So decimals would also be fine. Excuse me, in that case. All right, we had the parabola, the ellipse, and now the hyperbola on 16. And what we'll do on this one, I'll also draw a sketch of it. This was another one where I was asked for all the different pieces, was not asked for a sketch, but we'll get a sketch up here just for practice. And like I said, sometimes plotting it as you go helps find those pieces, right? Those quick plots. So this particular one, x is first. So that's going to make it a transverse axis be the x-axis. Or you could think of it as being a horizontal one. And what that's meaning is I've got this parabola opening to the left and opening to the right. The center, my HK value, -3, 2. So again, I'm going to draw this one even though we weren't asked for it. But I'll also stress, as I said before, if I'm more of a visual person and I struggle finding things like the vertices and such, then take a moment and graph as you go to help you keep things lined up. So -3, 2, there's my center. Let's see, A would be square root of 4 is 2. B would be square root of 16 is 4. So just a kind of a difference between the ellipse and the hyperbola. On the ellipse, the previous problem, A squared is the larger value. On the hyperbola, it's the first value, that 4. C squared is A squared plus B squared. So 4 and 16 is 20. So root 20. Again, we can write root 20. We could simplify the radical as 2 root 5, or even go to a decimal. So my vertices, 2 units, left and right, from the center. 2 units to the right would be at -1, 2. 2 units to the left would be at -5, 2. Okay. Root 20 units, so -3 plus or minus root 20, 2. Moving left and right. And then our last piece, the asymptotes. Make sure I was looking at the right problem. All right, asymptotes. Y minus 2 equals plus or minus. I know I've got an x plus 3. And then the part I have to remember is for the asymptotes, would it be b over a or a over b for a horizontal one? Or meaning the transverse axis is the x-axis. And that would be b over a. So I would have 4 over 2. And you can leave it like this. You could certainly reduce that slope to a 2. You could even distribute the 2 and write 2 different equations, but we're generally okay leaving it like that. That's also all I needed as far as plotting the asymptotes, because I know it goes through the center. So I'm going to go to my center. It's right here, and I'm going to count my slope. So the slope was 4 over 2, so I'm going to go up 4. And then over 2, so I'm going to be about right here. And then up 4, back 2. And if I had reduced that to 2 over 1, I would just be going up 2 over 1. It's going to give me the same lines for the asymptotes. Something like this. I'll get that one a little bit off, but still. And then I can fill in my 2 parabolas that make up my hyperbola. All right, 17. We switch to looking at a couple problems here with matrices. And the first one is solve the system using the inverse method. Okay. And the inverse of the 3 by 3 is given. Okay. So, inverse method. Means that I want to take the inverse and the inverse matrix write this down right, is 1, -1, -1, -3, 5, 2, 2, -3, -1. And we're going to multiply the inverse by the answer matrix, which is -12, 1, -9. And multiplying the inverse that was given there by the answer matrix. Now, I know there are other ways to solve systems: Cramer's rule, algebraic, inverse method, row operations. This particular problem asked me to do the inverse method, so I must use the inverse method to get credit. So I'm going to take my inverse times my answer matrix. So we're going to go row by column. So this would be 1 times -12 plus -1 times 1 plus -1 times -9. And I'm going to go row 2, -352 times my column. So -3 times -12, 5 times 1, and 2 times -9. And then my last row, 2, -3, -1 times the -9. So 2, or excuse me, times the column, 2 times -12 plus -3 times 1, and plus -1 times -9. And one of the things to notice, if you're taking the time to write out the multiplication steps, you'll see these numbers line up. Notice the -12, the 1, and the -9 we had right here. Now, it doesn't mean that we're not going to make any mistakes, but sometimes that can catch a careless error. If you kind of make sure things line up, generally, you know you're on the right track. You had everything written out correctly. And then we can just compute those pieces. And that's where I got -4, -23, excuse me, +23, and -18. So what this would mean as far as a solution, this would mean that x equals -4, y equals 23, and z is -18. Typically, we would see it written as -4, 23, -18 as an ordered triple. As far as a solution, it's fine as the ordered triple. It's fine as x equals y equals z equals. Whichever way you're comfortable with is fine. That's our inverse method. 18 says to use Cramer's rule. Okay, so now we specifically need to use Cramer's rule on 18. We're asked to solve for y and only the y value, and we're told that the determinant is -189. So here's what I know. Y would have to equal d sub y, the determinant with respect to y, over d, the base determinant. Okay? I don't know this d sub y, but I do know d. I was given that as -189. So I need to go figure out what that determinant with respect to y is, and we'll get that answer, but let's say it's 400, then I'll have 400 over -189. That would be my answer for y. So I need to go figure out this particular determinant piece. Determinant with respect to y. This would be where the answers, the 36, 30, and -3, are going to replace the y column. The x column stays the same, 8, 1, -5. And the z column stays the same, -1, 4, 1. So for d with respect to y, the answers replace the y column. Now this is what I need to go evaluate. I'm going to get that final answer for it, and I'll put that right back in here. So to evaluate my 3x3 determinant, I'm going to rewrite the first two columns. And we do get some bigger numbers sometimes on these, but we do have a calculator for the test, so it's not too bad if we end up with some larger ones. So we're going to go down diagonally. 8 times 30 times 1 plus 36 times 4 times -5 plus -1 times 1 times -3 so we went plus, plus, plus. Now we're going to come back the other way. Minus, minus, minus. I'm going to start on the far side. Minus 36 times 1 times 1 minus 8 times 4 times -3 and minus -1 times 30 times -5. So notice I had going down. I went plus, plus, plus. I used the parentheses where appropriate, so even like right here, I had a plus and negative, but I've got plus, plus, plus on those first three, and then minus coming back the other way, minus, minus, minus. And that gave me a grand total of -567. So now I'm going to slide this -567 in here. So -567 divided by -189 would be 3. So there's that y value using Cramer's rule. So that's solving using an inverse method on 17, solving using Cramer's rule on 18. Typically, when it comes to a test, as far as Cramer's rule is concerned, if we have a 3x3, you are typically going to be asked to solve for one variable, not x, y, and z, just because of the amount of time it takes to compute a 3x3 determinant. So that way you're just computing one of them. And I say one of them because you were given the -189, so we just needed to compute that one d sub y. Also, I wouldn't expect this final answer to be some really weird fraction, okay? I'm not saying it wouldn't be a fraction like a half or 3/4, something like that. But typically they would be nice looking fractions or an integer. So if you're getting something that is just not simplifying with this guy down here, that's a good chance that this number was wrong. Something happened over in here as far as a calculation error. Maybe go back and check. I'm not saying we're never going to get an answer like that, but typically not that bad of looking fraction. Usually means something kind of went wrong in the calculation. 19. An inverse of a 2x2. So I'm given the 2x2, -4, -4, 1, 0. An inverse of a 2x2 would be 1 divided by the determinant times the 2x2 matrix that has been rearranged. So this was what we had in class, the formula. So if I said A was A, B, C, D, then A inverse would be 1 over the determinant of A times D negative B negative C A. So the D and A switch places, the B and C switch signs. So let's follow that process here. So I'm just saying this matrix is A. Okay. So I'm going to have 1 divided by the determinant. So the inverse would be 1 divided by -4 times 0 minus -4 times 1. So the determinant, -4 times 0 minus -4 times 1 times, all right, let's see, that 0 and -4 switch places. And then these two switch signs, so -1 and +4. So that would be, let's write it right here, 1/4. So this would give me a 4 down here. 0 plus 4 is 4. And now I'm going to distribute that 1/4. And that would be then 0. 1/4 times 4 is 1. That would be -1/4. And 1/4 times -4 is -1. There's my inverse of that 2 by 2. Partial fraction decomposition. So it means we want to break this thing up into the fractions that it came from. When I see a denominator like that, x squared minus 5x minus 6, I need to factor it to know the pieces that it came from. So I'm going to factor this, and it would be x minus 6, x plus 1. Just going to cross that out there. That would be my factored piece. Now, one of the more common mistakes that I see when we're given a problem like this and asked to decompose it is it's factored wrong. Double check, make sure you factored it correctly. Again, I can check here, that would be 1x and -6x if I multiplied it back out, which would give me -5x. Just check the factoring, make sure that's right. Now my split would be a over x minus 6 plus b over x plus 1. It doesn't matter which one's first. I wrote the x minus 6 first simply because that's the one I had first when I factored it. Okay. If we put these back together, common denominator, x minus 6, x plus 1. That means a times x plus 1 and b times x minus 6 to build that numerator. Now, when I look at these two fractions, the two denominators are the same. They both have this. So that means the two numerators have to be the same. So there's my equation I can set up to work with. I know 2x minus 5 has to equal a times x plus 1 plus b times x minus 6. Now I'm ready to work my solving process to figure out what a and b are. This is where I selected values for x. I could select any value I want, but I want to select ones that are going to help me. In other words, they'll cancel out something. So I look at those domain restrictions. The best ones to select would be 6 and -1 because those are the two domain restrictions. So if x equals 6, let's see, 2 times 6 is 12, minus 5 is 7. 6 plus 1, that's 7a, and then 6 minus 6 is 0, so that b's gone. That's going to make a equal to 1. And then if I let x be -1, That would be -2 minus 5 is -7. Let's see, -1 plus 1, 0, so that one's gone. -1 minus 6 is -7b. And so b is also 1. So I had an a for 1 for the a value and 1 for the b value. My last step, once I figure out what a and b are, and again, they're not typically the same, just ended up that way. They were both ones here. I need to write my final answer, which would be the fractions. So 1 over x minus 6 plus 1 over x plus 1. That would be my partial fraction decomp. 21. Civics Theater has 22 seats in the first row, 21 rows in all. Each successive row contains 3 additional seats. How many seats total are there? This would be an arithmetic sum. Now, if I don't recognize from reading the problem that it's arithmetic, maybe just take a moment and write out a few terms. So we're told there's 22 in the first row. And then it said each row contains 3 additional seats. So that means the next row would be 25, then the next one is 28, and the next one's 31, so on and so forth. So that's enough to tell me, hey, wait, I'm adding 3 each time. That is an arithmetic sum. So I'm trying to find the total. That's telling me to sum up all the values. So my formula for the arithmetic sum, n over 2, a1 plus an. It's a generic formula. I have 21 rows. So 21 is the n value, 21 over 2 times 22 is the first term. That's how many's in the first row, plus a subscript 21. I need that guy. I don't know what how many seats are in the 21st row. If I knew it was 100, I could just put 100 in there, calculate it out. I've got my answer. So this is forcing me to go back and use my term formula. So that was my term formula for the arithmetic. So a subscript 21 would be first term 22 plus 21 minus 1 times that common difference of 3, which would be 82. Now I've got that 21st term, so I can put that into my equation here. 21 halves times 22 plus 82. And that gave me 1,092 total seats. $22. This is my infinite geometric sum. It's got a couple ways to recognize it. Geometric, you've got an exponent. So I've got a power sitting up there that's telling me geometric. Also, look, that infinity is not hiding. Right? So first off, I need to determine if it converges or diverges, because if it diverges, I can't find the sum. So just a kind of reminder here, the absolute value of r would be 1/4, which is less than 1, which means this is going to converge. If it was greater than 1, it would diverge, which means I could not find the sum. Right? In other words, the sum most likely infinity or something like that. Can't give you a finite value. Right? Since it is less than 1, it will converge. And this was my sum formula. A1 over 1 minus r. So the first term divided by the 1 minus r, 1 minus the common ratio. So let's see, the first term. If I put 1 in, 1 minus 1 is 0. So negative 1/4 to the 0 power is 1 times 2 is 2 over 1 minus the r value is negative 1/4. Be careful there, that r value is negative 1/4. So that's why I've got 1 minus a negative. 1 minus negative 1/4 is actually 5/4. And so 2 divided by 5/4, that's what gave me 8/5. If you're more comfortable in say decimals, and 8/5 would be fine as 1.6. That would be okay also. All right, that's the last ones from that review there.